First question, does the influence of gravity extend out forever? Well, when we're looking from an earthly standpoint, no, because even though the Earth seems pretty big to us, we're nothing but a speck of dust in the vast majority of just the overwhelming everything of the observable universe. However, if we're looking from a matter standpoint, any object with mass, even if it's just one singular atom that seems to be like devoid of all other anything else, as long as that one atom in that cubic area of space exists, there will be some minuscule amount of gravity with influence. For example, if we were to put my two shoes in a vacuum, even at this size, way past the atomic level, their force of gravity is still pretty minuscule in itself, and it would take a while, but eventually they would collide and hit together like this. They're like, ah! And it wouldn't be that much, but yeah. Even me, myself, I have an influence of gravity, a little more than the shoes, so stuff could be attracted to me too. Hey! What the heck are you doing? Cut it out! Alright, let me try to catch that. Here, try again. Let me try to catch that. Oopsies.
So, if the sun's actually too hot to get near, how do we record its temperature? That's a pretty good question. If we can use a law made by Wien
That's pretty cool.
to figure out its temperature. So, if we look at the equation, let's see the equation. So, if we look at the equation, we're going to use some things. So we're going to use wavelength max. You probably can't see that now, can you? We're going to use wavelength max, and that equals 3 million Kelvin nanometers divided by temperature in Kelvin. Now, what we can do is multiply the temperature in Kelvin to cancel those out to get it over here. I'm going to just easy do this. And then we're going to divide lambda max over. So what this gives us is the actual temperature, which is 3 million KNM divided by lambda max. Now lambda max is actually around 500 nanometers, roughly. So if we cancel those out and we do the math, we get temperature equaling 5,778 Kelvin.
So, is it possible to go the speed of light? Well, what we believe is that any object that has some sort of mass cannot go the speed of light, as we presume light to be massless. The speed of light is 3.0 times 10 to the 8th meters per second. Clearly I have mass, and boy oh boy, I don't think I'm gonna go that speed. But our logic is almost flawed because we believe certain reaches of the universe are expanding away faster than us, than the speed of light, despite them having mass, even if they are galaxies or something else. So this logic is sort of flawed unless dark matter has a play into it, but as we're going to see here, I'm going to go through a spiritual ritual where I excrete all of my mass in my own sort of internal supernova, where all the matter that comprises me will be gone. And then it'll be massless. And then I'll show you I can go the speed of light. I forgot how intense that process is! Come on, fellas, let's go watch me go the speed of light! Sorry, Mr. Krause, I'm making a video.
The universe is constantly expanding. What is it expanding into? What exists in the areas where the universe has not expanded into? I really can't give you a good answer because no one knows. No one has actually ever been that far. So the best would be a theoretical answer, and the only one that I can come up with is it's just nothing. Like, it's more nothing than space with nothing in it. I don't know if you can imagine that. It's just nothing. There's just nothing to it. There's nothing.
Wow.
How many stars are in our solar system? One.
So, is time different in space or on any other planet? As a matter of fact, yes. It's something called gravitational time dilation, which states that the more massive an object is, like the closer you are to that more massive object, the more warped the time becomes, in a sense that it goes slower. We can think of time as a linear path, and the more massive an object is, it has more potential to bend that linear path of time, and it basically, when it bends that path of time, instead of going straight from point A to point B, this point A to point B is now warped, and it'll take the time longer to get there. No matter if I'm on this linear curve or this curve, the time, I will perceive it the same, but relative to someone else, they can see my perception differently, but I won't notice the change. An example of a linear path of time. Ouch. Here's an example of a curved path of time. Ow, the weight of time! As you can see, that time's path was curved, so it took longer to get to me. But from my perspective, I couldn't notice a change, whether it came straight or from that curve. Someone else could witness the change. That's where the whole relative time comes in, but I myself, with no other thing to compare to, could not witness that change. Ah! So, what is the first star spotted in the sky? Name. What is the first star spotted in the sky? Name. Well, I can interpret that a lot of ways. Are you talking about the first star we see, like, throughout the day, like the sun? Are you talking about the first star that was formed that we can see, what name that is? I mean, this is a very broad question that I don't understand, and I hate trying to come up with all these answers for it, because no matter how I interpret it, there's some stupid loophole that's got to be solved. Like, what if the first organisms that couldn't have functioning eyes, what if they formed it, what if their eyes started functioning at night? So how on earth are they supposed to? We don't know what they said. We don't know. How is the first star we seen, so we know what the name of that one is, because we took a god of time trying to name these, because that's what we cared about, not photosynthesizing or eating to survive, because survival in this life is just not worth it. But you bring up an excellent point. That question's so broad that I don't want to answer it. What is the first star in the sky name? What's the first star in the sky? Is it the sun? I mean, it has the honor of being called the sun, to where we can base all the other ones off of, but what is the first star in the sky? Are you talking about at nighttime, whenever Venus tends to be one of the first bright objects you can see in the sky? I don't know what you're talking about. Kill me.
If the Earth was flat, how would the other planet be flat in the sun? How would the rotation of the sun work? The other planet? Earth 2? What other planet? There's a couple of them to choose from. The other planet would be regular, just like Earth, round. How would the rotation, good one, of the sun work? The Earth was flat. The sun would still rotate the same. Oh, excuse me, rotash the same. R-O-T-A-S-H-I-O-N. Ooh. Man. Just want to let you know, whoever wrote this, Coral gave you a question mark. Just be mindful of that. He gave you a question mark. I don't know what you're trying to ask. That's the best I could decipher it. But ask Mr. Coral a better version of your question.
I have the wrong question. Oh, there it is. Sorry.
I'm still keep recording.
So, how far away is the nearest planet from us? How far away is the nearest plant from us? Well, that's actually a really good question. To figure this out, we can turn on my bovine persona. Oh, sorry, I need to turn down the swine a little bit. Everyone get off my time! Better stop.